In this video, we'll explore what can be achieved with the Raspberry Pi Pico 2W. More specifically, I'll be pushing the limits of this small yet powerful microcontroller development board. I've named this project SensePi. Using a variety of sensors and modules, we'll create a project that is both educational and fun. Together, we'll discover the true potential of the Raspberry Pi Pico 2W. Before we get started, don't forget to subscribe, like the video, and turn on the notification bell. Let's get started. In this project, we will use the Pico ResTouch LCD 2.8 display. It is a 2.8-inch TFT touchscreen with 240 by 320 resolution and works with the Raspberry Pi Pico. It supports both display and touch. We will show sensor data on the screen. The HCSR04 ultrasonic distance sensor measures distance using sound waves. It detects objects in front of it and is commonly used in robotics and obstacle detection. Our next sensor is the DHT11. The DHT11 is a simple and widely used sensor that measures temperature and humidity. It provides digital data to microcontrollers. A passive buzzer produces sound at different frequencies for alerts and tones. We will use it for audio notifications. The MPU6050 is a 6-axis accelerometer and gyroscope sensor. It is used in motion-based applications like seismometers, spirit levels, and pedometers. The 3-watt LED module is a powerful light source. I will use it as a simple lamp in this setup. By controlling it with a microcontroller, we can turn it on and off and light up the environment. A rotary encoder is a control component that allows position and direction selection by rotation. By turning it left or right, we can navigate menus and press the button to select. I will use it for menu control in the SensePi application. On this PCB, I soldered header pins. I did this to distribute the 5 volts, 3.3 volts, and ground lines coming from the Pico. This power distribution will be necessary in the later stages of our project. This makes it easier to power multiple components. I made a cable that goes into the Pico instead of the USB micro. With this setup going to the regulator, I safely power the Pico. I use a 12.6 volt 3SLIPO battery pack with a BMS, which provides protection and stable power. The system also includes a jack input for charging and a power switch for easy control. I take power from a 5 volt 3 amp USB output regulator and feed it directly into the Pico's USB input. This creates a portable and safe power system. I created a 3D model for the SensePi case. I designed both the front and back and prepared spaces for the display, sensors, and modules. Honestly, I didn't have much time, so it didn't turn out exactly as I wanted, and I had to use double-sided tape for some modules. Still, I will use it in this project and improve it later. Now, if you're ready, let's move on to the assembly. Hey everyone, you didn't see this QRE1113 sensor when I introduced the modules and the Pico at the beginning. I decided to add it to the project later on, so consider it a nice little bonus for you guys. This module is actually an infrared reflectance sensor. Thanks to its IR light, it can detect hand movements without any touch. In this project, we'll be using it for an awesome feature, to trigger and wake up the system from screensaver mode. Well, let's move on to the assembly. Our device is finally finished. We turn it on by sliding the on-off switch right here. The screen lights up and the SensePi application, which I coded entirely myself using Python, welcomes us. Actually, in this educational video, I designed this device to fully demonstrate the performance and power of the new Raspberry Pi Pico 2. Through a sleek menu, we can fetch the atomic clock, real-time weather, and currency exchange rates. There are also great tools I integrated into the software, such as a digital spirit level, pedometer, distance measurer, room monitor, and an earthquake sensor that detects vibrations. From the settings section, you can monitor the Wi-Fi status, track RAM and uptime via the System Info menu, manage volume and brightness, and even restart the device. Plus, it's possible to switch the application into a stylish screensaver mode using the contactless infrared sensor. Now let's dive in and test all these features closely. Let's test the SensePi. I'm really happy with how the SensePi turned out. Everything works exactly the way it's supposed to. However, I'm still not completely satisfied with the 3D model. I developed the SensePi application in Python. I'll be releasing the full open source code on my GitHub, along with a step-by-step installation guide. The code is completely free to use, and you're welcome to customize it however you want. You'll find all the links in the description below. I'll also provide the STL files for the 3D model, so you can print and build your own version. This video shows you the true power of the Raspberry Pi Pico 2. Now that the SensePi application has successfully started up, let's jump right in and do our very first test. We are doing our very first test in distance measurer mode using the HC-SR04 ultrasonic sensor that I placed right at the front of the device. As soon as we open the menu in the app, our sensor starts working in real time and displays the distance to the object ahead with pinpoint accuracy. As you can see, the readings are incredibly precise, matching the physical ruler right next to it perfectly. Next up, we are testing the digital spirit level application, which utilizes the built-in MPU6050 gyroscope and accelerometer sensor. Once we enter the app from the main menu, a circular target interface appears on the screen. As I tilt the device, you can clearly see the green cursor moving accordingly. The best part of this feature is definitely the audio feedback. When we place the device on a flat surface and hit the exact center, perfect zero, the buzzer kicks in with a sharp beep. This allows us to easily know the surface is perfectly level without even looking at the screen. Next up, let's test one of the most practical features of the device, the flashlight mode. We tap on the flashlight icon from the touchscreen menu and then press the on button on the interface. Right at that moment, the 3-watt power LED module on the side kicks in. You can easily see how powerfully and clearly it illuminates the environment, even in a pitch-black room. We've achieved a really bright and successful light output that could be a lifesaver in emergencies. Thanks to the QRE1113 contactless infrared sensor I integrated into the side of the device, you can instantly switch SensePi into screensaver mode just by bringing your hand close. In this mode, the device enters low power consumption while continuing to display the time, date, and real-time weather information with a modern and sleek interface. Next, it's time to test our internet integration. When we tap the weather icon from the menu, SensePi fetches live data over Wi-Fi. As you can see, it perfectly displays the current temperature, humidity, and wind details for my city, Izmir, along with a complete 7-day forecast. In clock mode, the device automatically synchronizes the time when connected to the internet. But even if the connection drops, the built-in hardware RTC module keeps tracking the precise time and date completely offline without missing a beat. To test the DHT11 sensor on our device, we enter the room monitor mode. As you can see on the screen right now, we can track the room's real-time temperature and humidity fully live, stably, and with high accuracy. That's it for our SensePi project. You can find the links for the 3D.stl files and the source code down in the description box. I really need your support to keep going, so please don't forget to like, comment, and subscribe to my channel. Thank you so much for watching, and I will see you all in the next video. Take care.